Good morning, good afternoon, wherever you may be in the day. As always, thank you for choosing to make chemistry part of your day. This should be short and sweet. We're going to take a few different ways of representing an atom or an ion and figure out the number of protons, electrons, and neutrons. As promised, how many protons, electrons, and neutrons are in an atom of cobalt-60 used to actually sterilize food, such as your eggs, so you don't get salmonella and puke. Those kind of ideas. All right, so cobalt-60. First thing we need to do is we need to find our friend, the periodic table. I've chunked out pieces of it for us as we go along. And we need to know that cobalt is Co. And it's not Cu or any of the other things that might be up there. It's just C. It's Co is cobalt. So we got to learn those. We just do. It's going to help us do problems. It's going to help us understand what we're looking at. So cobalt Co, we go to the periodic table, we find the block with cobalt. And depending on the version of the periodic table you're using, sometimes the big numbers on the bottom, sometimes the big numbers on the top. One of the numbers is bigger than the other, and the smaller number is a whole number. So that smaller number, the whole number, that's your atomic number. That is the number of protons. So the number of protons is what makes an element an element. Every single atom of cobalt in the entire universe has 27 protons. So that's super easy. We just read that right off our friend, the periodic table. The other number, for these types of problems, we actually want to ignore. Yes, it's a mass number. Yes, in theory, it should be helpful, but that's an average mass. We want the mass of the atom in question, not an average, not all atoms, but our atom. Our atom here is 60. That's the mass. That'll be given to us. And that is going to be your protons plus your neutrons. So if we subtract out the atomic number, sometimes Z is our symbol here. If we subtract that out, so if we take the mass minus that, that'll give us our number of neutrons. So if we do 60 minus 27, ideally without a calculator, we're left with 33 neutrons. And typically there's a few more neutrons than protons, so this makes sense. The last one is electrons. Protons and electrons have equal and opposite charge. So if they tell us nothing about the charge, which they have in this problem, we assume that the charge then is nothing. We assume it's neutral, and if that's the case, the number of protons and electrons would be equal. So the answer to this question would be 27 protons, 27 electrons, and 33 neutrons are in an atom of cobalt-60. Hopefully that was pretty straightforward. You might ask, what do we do if there's a charge? And I'm glad you asked that, so let's take a symbol like this. 32s, 2 minus. How many protons, electrons, and neutrons are in there? And I think this is one of the things that causes a lot of trouble when people are learning chemistry, is we put numbers everywhere, and we expect you to know they all mean very, very different things. So let me just take a moment to deconstruct our symbols. The capital letter, sometimes followed by a lowercase, sometimes not. So that could be SC, or just S by itself, or SI for silicon. Every capital letter designates an element. So in this case, big S means sulfur. In the case of Superman's chest, it means the house of L. It doesn't mean super. Upper left is our mass. Upper right is our charge. Bottom right is the number of atoms. And if nothing's there, we assume that it's 1. Bottom left is protons, usually left off because they assume you can get it from the periodic table. Out in front, if there's a number, again, if it's not, we assume there's 1. Tells us how many of the things that follow, or how many units we have. So all these mean different things, so that causes, admittedly, that causes quite a bit of confusion. So just to deconstruct that. So we get a symbol like this, upper left, that's our mass, upper right, that's our charge. So we know that if we're doing protons, electrons, and neutrons, first thing we have to do is find the symbol in the periodic table and find the smaller number. That is always our number of protons. That part's pretty easy. Realizing that the nucleus has all the positive and negative charge, all the mass and all of the positive charge, and the electrons are on the outside, the way atoms change charge is changing the number of electrons. So if we have a -2 charge, that means we have gained 2 electrons. So if we gained 2 electrons, it means we have 18. So we have 18 negatives, 16 positives, and check yourself. Okay, so I got 16 positives, 18 negatives, that's -2, and yeah, that matches what I'm supposed to have. You can always do that. These are easy questions. Make sure you get them right. Take the extra time. I don't care how long you take on a test. and that'll give us that. The other way of looking at this is if you take the number of protons, if we take the atomic number, if we take the protons, and we subtract the charge, that will give us our electrons. So in this case, we take 16 minus 2, gives me 18. So if you want a mathematical formula, that's what it is, but you can also use common sense. We gain 2 electrons, negative 2 charge. Again, we ignore the average mass. We look at the mass up there, and we take the mass minus the atomic number will give us our neutrons. So in this case, we have 32 minus 16 leaves me with 6 neutrons. So my answer is 16 protons, 18 electrons, 16 neutrons, and hopefully that's not too bad. You can stop here if you want. I'm going to do one more example just to make sure you got it down. And let's take carbon-14, which we use for radioactive dating. It's formed up in the atmosphere. And let's say it's been ionized to form a positive 4 charge. And we want to know our protons, electrons, and neutrons. So first thing is we have to find C on the periodic table. There we go. And just to keep you on your toes, I flipped where the atomic number is, and we want to find the smaller number. So I found the smaller number. That is my number of protons. And I'm already a third of the way through the problem. Now remember, we gain and lose negatives. Sometimes confusing because usually we like to think of things in the positive quantity. But we're talking about gaining and losing negatives. So if we have a positive 4 charge, that means we've lost 4 electrons. Or the protons minus our charge, so 6 minus 4 leaves me with 2 electrons. Lastly, the neutrons is going to be my mass. Not the mass from the periodic table, but the mass from the problem. Minus my number of protons leaves me with 8 neutrons, 2 electrons, and 6 protons. I hope you enjoyed this. And I would call this problem quite easily done. Have a wonderful day, and I look forward to seeing you in class.